So often there's a lot of focus on the tooling, data platform tooling that can make data use efficient at scale. But in our experience, this has to be driven by also the effective application of data to solve business problems, and that's not just a technology problem.
From Toro Cloud, this is the Coding Over Cocktails podcast, a free pour of thoughts and ideas from IT experts, thought leaders, and authors, sharing their insights and advice for individuals architecting solutions for the ever-changing landscape of enterprise tech, digital transformation, and more.
Welcome to episode 77 of Coding Over Cocktails. My name is David Brown. Our guest for today is an innovative technology leader with over 20 years' experience leading the strategic and technical delivery of data and AI, delivery strategy and change solutions. He combines diverse experience delivering complex technology solutions with his passion for customer outcomes to develop high-performing teams capable of solving complex client problems. He is currently a Director of Data and AI Practice at ThoughtWorks Australia and oversees all facets of developing data and AI capabilities and service offerings. Joining us for a round of cocktails today is David Colls. Hi, David. Great to have you on the show.
Hi, David. Thank you for having me. Thank you for the intro.
Absolutely our pleasure. Can you run us through your role at ThoughtWorks to get us started?
Yeah, sure. You provided a good overview there, and while I described overseeing all aspects of data and AI capability, I think that as our team has grown, my role has become more about planting seeds and pruning what germinates from them, working with the specialists in our team across the range of services we provide. So if I think about the dimensions of the role, it's partly one of the dimensions is the different services that we provide, from data strategy through data engineering and platform development, data governance and data mesh, intelligent products and AI solutions. And so one dimension of the role is being across what we do in those different services and how those services complement one another, and also complement the broader offerings of ThoughtWorks as a digital delivery and advisory consultancy.
Interesting. I mean, we have a number of guests from ThoughtWorks, and when you say specialists, you guys really are, and you tend to be thought leaders in a number of spaces. I'd be interested to get your perspective. You're another fellow Australian based in Melbourne, in Australia. I'd be interested to get your perspective of the Australian landscape versus the international landscape. How are we doing here as Australian companies in terms of our embracing digital transformation initiatives and data initiatives and AI?
It's a great question, and it's one that comes up as we collaborate globally within ThoughtWorks around our data and AI services. What we do find is that the market in Australia is a bit different in terms of the composition of our economy and industries compared to, say, the other global north markets like North America and Europe. But we find as much innovation in Australia as in those other markets. And so, we see a lot of innovation in our digital native homegrown exports, our Atlassians, MYOBs, Xeros, REA Group are organizations that we work with. And so we see that those organizations are leading the way in data engineering and ML practices as much as other organizations globally, however, with a different industry focus here.
Interesting. That's good to hear. Well, talk about data capabilities within organizations. It's a phrase you've used yourself. What are you encompassing by data capabilities? It sounds, very broad.
It is very broad indeed. And I think it comes down to probably effective use of data to achieve an organization's objectives. Being able to do that efficiently as well at scale so as to make it economically, and also to be able to do that safely. So understand safety aspects of applications, but also safety aspects of handling data. And so I think that all of those come together to create an organizational capability to work with data. And if you're looking at developing that capability, then you're looking at developing those axes together. And so often there's a lot of focus on the tooling, data platform tooling that can make data use efficient at scale. But in our experience, this has to be driven by also the effective application of data to solve business problems, and that's not just a technology problem. That's a people and process and organizational design and culture problem to address as much as a technology problem.
We've talked about that extensively, the cultural aspect of these initiatives as well. And I know you like to embrace a lot of machine learning and AI in your data initiatives as well, data capabilities. So we are going to talk about that. But before we get into that, I'd like to talk to you about data mesh. You have recently been talking a lot about data mesh. In fact, we've talked on this podcast about data mesh and I've had some leading experts on what a data mesh is. So we don't need to go too much into what a data mesh is, but I would be interested in getting your perspective about how it's being used. What are some of the practical applications of data mesh?
What we're finding towards that description of organizational data capability is that being able to build effective data solutions, but also in a timely manner, is a key driver for organizations looking to pick up data mesh. So often they have they have large data sources internally. They have some technology to manage it, but when it comes to bringing all of those capabilities to bear to deliver new data initiatives in short timeframes, we're finding organizations limited by their existing infrastructure, and that's where they're looking towards data mesh to support those use cases.
When you say they're limited by the infrastructure, what sort of limitations are you referring to? In the digital world, I think, we've seen over the last decade the problem of rapidly bringing digital products to market, more or less a solved problem now. We have a range of approaches to identify customer needs, to rapidly test and refine products, and we have continuous delivery practices and architectures that support rapid evolution and scale. But in the data world, we're often coupled to more legacy centralized data infrastructure that makes it hard for teams to autonomously make the small changes they need to with short feedback cycles to deliver data products or digital products that are driven by data features. So I'd like you to, if you could, give me a practical example. I've read, for example, you've talked about the airline industry as one where they have these enormous data silos, and some of the practical benefits of retaining those close to the owners of those data silos, and how the data mesh can overcome some of those challenges. Can you run me through some of that practical implementation?
Yeah, so often with a centralized data program or data infrastructure, there are multiple hops for a team to go through to be able to deliver a piece of functionality. The first hop, and each of those brings some delay. And so the first hop might even be identifying who owns the data internally and who can authorize its use for another purpose. And that can take weeks or months, which is the type of delay that can severely compromise product development activities. And then even when the data's identified, then there might be an additional process of building the pipelines to get the data from A to B, and so that can add more delay into the process. Then when the data is available in an environment to build a product off it, then often there's another team involved to actually build algorithms and serve the data into a consuming application. And so in that paradigm, we see delays at every step of the way, and the silos in the airline industry would be an example of that. The alternative is, and it's a gradual transition to bring those data sets, to bring ownership and autonomy over how those are published closer to the source, to be able to rapidly validate the consumers are getting value from the data, and to be able to do that in a decentralized way, to build governance affordances into data products and into the infrastructure as well. And so these are things like, does it publish the information that consumers need to use? Can we see its consumption patterns? Does it conform to standards within the organization? And inevitably, in a decentralized world, there'll be competing objectives as well. So then how do we work through those competing objectives and resolve those?
And is it data mesh versus data warehouse, or is it horses for courses where both architectures suit different problems?
Yeah, I think it is horses for courses to an extent. I think that we see that like a data warehouse might become a part of a data mesh. So it might be a solution for a particular domain, where there is a need for that type of data modeling that a data warehouse supports. But it also depends a bit on the size of the organization as well. So smaller organizations might and organizations that are building their digital maturity might find that the overhead of running a data mesh doesn't provide the additional organizational agility that they're looking for.
Yeah.
But I think in terms of that digital maturity, I think the tooling will improve over time, and we'll see it becoming easier and easier to stand up.
It reminds me of the arguments for and against monolithic architectures versus microservices. When you're starting out, a monolithic architecture is actually easier and perfectly viable architecture. But when you get to scale, perhaps a microservices architecture can offer you the benefits when you're at that stage.
Yeah, I think there's a lot of parallels in that journey.
Well, let's talk about AI. So I know you are very interested in AI and the use of data and creating product opportunities out of AI. Now, it's traditionally been used for analysing historical data to improve a customer experience. But in the last few years, you've been promoting this concept of using AI for a business planning or product development concept. These areas have normally been the domain of a business manager or someone with expertise or accumulated knowledge in regards to that product knowledge or business knowledge to make those strategic decisions. So they're using their accumulated knowledge plus some intuition about the market and the customer expectations. How is AI changing this approach?
Yeah, it's a great area to address, especially currently as business conditions are so dynamic. That question of business strategy and product development, that it has been addressed differently in different industries over time. And prior to ThoughtWorks, I worked in the automotive design space where, with a new vehicle design, it was possible to generate thousands of variants, simulate their handling, their aerodynamics, and their crash performance, all inside a computer, all in a matter of days, to get very early feedback on product performance and what good product designs might look like. And so, that sort of virtual prototyping approach has been around in some industries for decades. But what we're seeing with now more powerful, more flexible AI tools, a greater ecosystem of open source solutions and data means that sort of approach to product development and business strategy as well can be applied in a much wider range of circumstances that almost any business can take advantage of. And so we've seen it used in designing call center systems, in optimizing airport operations, in even developing new blends of whiskey. So these are all opportunities to apply, and sustainable supply chains as well. So these are all opportunities to apply AI techniques in product development and business strategy. And I think the key of using them is not to outsource all the design and decisioning to AIs, but it's to do it in a collaborative fashion with the human expertise. So we don't lose the human expertise. We just formalize it. And what we see is then using AI techniques allows us to explore more designs or more possible futures that we wouldn't have considered otherwise. It also gives us that fast feedback loop potentially, as in the vehicle design. So we can test a lot more designs than we would have otherwise.
So obviously there's going to be lots of inputs of data to this process. So if you're designing a whiskey using AI, what would be the inputs in that process?
So it's basically all the decisions that go into making a product are in scope for this type of approach. But as you work through iteratively, you'll pick thin slices and identify the areas where you can have the most impact on the decision-making process. But for a whiskey example, it could be sourcing all the raw ingredients, where those ingredients are sourced from, can be all of the brewing and distillation and aging processes as well. The time, the process parameters, pressure and temperature, and everything that goes into actually producing the final product can have an impact on its performance in the market. And the performance in this case comes down to taste. And so we were able to establish a relationship between some of these design parameters and the expected taste, or the dimensions of the tasting notes of the whiskey, and so then provide a model which could generate new inputs, and even to the degree of choosing between single malt whiskies to create a blend with appropriate tasting properties. And then provide that tooling to the master distillers who are ultimately responsible for producing a product that they think the market is going to enjoy. So all of those inputs can be brought together and presented to the human experts responsible for these product design decisions.
It's a really interesting use case. I'm interested to hear about something about that call center example you're talking about as well. But I'm just interested with developing whiskey using AI, and you mentioned a number of the inputs such as ingredients and distillery methods and presumably customer preference in terms of taste. What kind of algorithm are you using for that? Are you sourcing one which is off the shelf? Are you writing one from scratch? Where do you start?
In this case, a general set of techniques, a generative adversarial network was applied in this case, but there are depending on the product and depending on how you want to assess it, there are a range of different techniques you might use. For the call center example, for example, that was using an agent-based simulation. So each caller was modeled as an individual agent who had some patience to wait on hold, who had some reason that they were calling, and who had some tolerance for being transferred from agent to agent until their query was resolved, and as a result generated an NPS score for that interaction.
Yes.
And similarly, on the organizational side, there were agents representing the real contact center agents who had similar behaviors that could be simulated. Add to that actual a model of the planned production systems that would determine which calls were sent to which queues serviced by which agents. And then you have in this case, actually a custom simulation model based on custom agent behaviors and custom routing systems. And then that's a model that can be run with different parameters. We can establish the trade-off between cost to service and customer satisfaction with various designs.
Well, that customer service example, the call center example, you're talking about a lot of historical data being used to create those models. To train a machine learning algorithm, you typically have a good data set of historical data. Now, some organizations won't have that data. Many will have historical data which they can feed into this algorithm. What are the options if you don't have an existing data set? Is AI still an option for your business?
Yes, I would say it absolutely is. And we really encourage people not to be constrained by the existence of historical data sets. What we do find is that even having a historical data set isn't a guarantee of success. So there may be missing data, there may be quality problems, there may be a lot of feature engineering required to get a historical data set into the shape that's required for supervised machine learning. There may be biases in the historical data, including it may no longer be relevant, especially, we've seen over the last 3 years with COVID changing consumer behavior again and again. Old data set, historical data has become less relevant in making predictions. And also we find that, once you start running a solution, the data will be evolving over time as well. So we always encourage people to think in terms of an ongoing curation process for a data set, rather than starting from mining an existing vein or resource of historical data. But it's a process that will be actively ongoing and evolving.
So what is that curation process? You're talking about developing data through experimentation, or
yeah. So depending on the application as well. So or it might be a process of starting to collect data in a form that you want to be able to use it and that's amenable. So in this case, you might consider that if there's a system that users are interacting with, that you wish to be able to add some AI capability or machine learning features to, then start thinking about how those users can provide implicit or explicit guidance as to the right decisions to be made. So that kind of labeling interface. There's a range of ways and so we can start, for instance, a recommendation system without any historical data. If we use a reinforcement learning approach, where the solution will run its own experiments and learn what works and what doesn't work.
So I think some people wouldn't be familiar with that term, the reinforcement learning. Run me through that.
So it's a process. There are, I guess, sometimes we describe 3 major classes of machine learning solutions. And those are unsupervised or self-supervised learning, which allows us to identify clusters. For instance, it might be used in segmenting a customer base behaviorally to identify different patterns of behavior that might identify behavioral segments. The second is supervised learning, which is what a lot of people think of when they think of machine learning, which is we provide a labeled set of examples of what good looks like. So this transaction is fraud, this transaction is not fraud, this customer is likely to churn, this customer is not likely to churn. And then a model can learn how to predict those labels or other features on new data that wasn't part of the training set. And then a third paradigm is called reinforcement learning. And in that model, we treat the system as an agent that tries to figure out how to get the best reward in an environment. And so the agent has to run some experiments and see what happens as a result. And so we might have a reinforcement learning agent. Say we have a video streaming service and there's a preview for each piece of media. The reinforcement learning agent might have half a dozen different choices for a preview image for each piece of media. And then it would learn based on some attributes of the user, what they're most likely to respond to. And over time, through trialing different preview images, it would eventually select the one that leads to the highest engagement or in the content.
Yeah, so it's basically creating that labeling process on the fly. So as the
it's a good way to think about it.
Okay, so interesting. It's so much opportunity. I think that is this in terms of product development and business planning through AI. Is this something that you see occurring a lot in organizations, or is this still in its infancy where you're educating organizations on this?
I think there are pockets where it's where the maturity is quite high and these techniques are being explored. But across the breadth of organisations, there are still a lot of opportunities to adopt these techniques.
Now, ThoughtWorks recently published a playbook called the Modern Data Engineering Playbook. It aims to help deliver greater value to businesses by pursuing data engineering projects, no matter the industry. Can you give us a run through of the themes in the Modern Engineering Playbook?
It's it's a technology agnostic approach to data engineering. So we focus on product management for data, delivery practices, technical practices, and team organization for data initiatives. And we wanted to structure it this way because in our client work, we work with a range of technology stacks, but we find consistent practices in how we deliver to be effective regardless of the technology stack.
Makes sense.
And so, yeah.
Is the playbook available to everyone, or this is exclusively available to ThoughtWorks clients?
No, it's available to everyone. It's published on our website currently, and we've released the first 5 of 7 chapters, and there are 2 more. The final 2 coming as fast followers. Yeah, and it's
so I'm looking at it in front of me.
Team effort.
I'm sorry, it's a team effort, did you say?
Yes, yeah. So, lots of different authors and a collaborative review process. So it really was bringing the thinking from different people and different engagements together into a playbook.
It seems quite comprehensive. I've got it open in front of me right now. So I'll just run through those 7 chapters. You've got treating data as a product, which is already published. Data engineering practices, also published. Getting the most value from your team. Data delivery principles, and then the ones coming and data quality, all published. The ones coming soon is project architecture and security and privacy.
Yes.
I would also like to ask you about ethical and societal implications of the growth of big data, which has been a big driver of machine learning practices and AI, and the practical use cases of AI. We've seen certain things like, I forget the terminology used, but in China they have the social record or social status, which is basically analyzing big data and applying it through algorithms. What are some of the concerns and implications of this data? I know the data privacy legislation in the EU also has some potential implications on how you can use AI and what you have to explicitly advise people how their data is being used as well.
Yes. I think there are a lot of ethical implications of using data, and they should be front of mind for organisations. And this is kind of the safe element of building data capability, because and you can think through different levels or different layers if it helps as well. And so, but I think that the general theme is that poorly governed automated decision making can disproportionately affect vulnerable people, and they are least able to redress the impacts of the automated decision making. And so if we, keep that frame in mind, we can look at it from different levels, the structural, societal level of, do we want to make these decisions with automated systems? And so, that leads into the questions of ubiquitous surveillance. Is that something that we want to accept as a society? How do we protect workers in an environment where, that a lot of their agency might be controlled by automated decision making as well, as a first layer. And then we kind of come to the question of data security and privacy. As you said, if an organization is a custodian of its customers' data, or other people's data, how are they a responsible custodian? How do they ensure that they're taking the right steps to preserve the security and privacy of that data?
And it's not just an ethical consideration either, right? There are legal implications such as GDPR in the EU and the like, which is actually expanding in scope to cover these types of things. Is that right?
Yeah, absolutely. And I think that it's the legal implications are almost a formalized form of ethics. So they provide really clear guidance about how you avoid doing harm to the stakeholders with data, and then we can go beyond that to the ethics of algorithmic decision making. So we have we considered what decisions we think we should be making. If we considered the handling of the data, then we've got concerns around garbage in, garbage out with algorithmic decision making. We've got concerns around historical biases being reflected, being perpetuated, and even being exacerbated by algorithmic decision making. And then we've actually got the case that algorithms fail as well. So they're not perfect at scale. Those failures may be not insignificant.
So what role or who within an organization should be responsible for that ethical oversight?
Yeah, it's a great question. And I think as technologists, I think there's an element of all of us being responsible technologists and understanding the impact of our actions. I think there's a role for government regulation and frameworks as well. And then there's a role for tools and processes to support us in those objectives. So bias testing tools and so on. But I think it's throughout we see it as like a process that gets built in, or an activity that's built in throughout the delivery cycle. So it's not necessarily a sandwich activity of upfront, but there's we set the ethical path, and then we check for compliance at the end of a project. But it's an ongoing process, and so everyone involved in delivery would have a role to play in that. And research and our experience shows that diverse teams have better outcomes in that regard as well. They're able to consider more scenarios.
We've talked about that on our podcast, actually. It's quite interesting how the benefits of diversity in that regard. Are you actually seeing like an ethics officer to oversee such projects as well?
I know we have. We've worked with organisations that have that function, and I can see it becoming a bigger part of delivery as AI gets built into more services.
David Colls, really interesting to talk to you today. Where can our listeners follow you on social media?
Oh, great. You can find me. I'm most active on LinkedIn. You can find me there.
And your handle is David Colls.
That's correct.
And of course, you've also written some blogs on ThoughtWorks.com as well.
That's correct. You can find our data and AI practice. We have a series of short blogs that we aim to publish quite frequently as well. I can provide those links if that helps.
Terrific. Thanks you very much for your time today, David.
Thanks, David.
Hey listeners, thank you for joining us in this round of cocktails. Please like and subscribe to check out other episodes of this podcast series. We're also available on your favorite podcast platforms, or you can simply listen in at torocloud.com, where you'll find full episode transcripts and show notes. On behalf of the team here at Toro Cloud, thank you very much for listening to us today. This has been Kevin Montalvo for Coding Over Cocktails. Cheers!